Today we'll be looking on how to get user input from the keyboard using assembly, and just let's get straight into it. I'll be using nano as usual. I will name it input.s. Then we'll go ahead and define our section text. So section text. Then define our global start as usual. Then we will use our symbol like that. So getting user input entails just placing some numbers inside some system calls to tell Linux what you want it to perform. So we have seen in the previous video when I have recorded how to print something inside the standard output or in the terminal. We used some system calls to maybe make that happen, but I will be showing you how we'll do system in or getting an input from the user. So for doing that, we'll go ahead and define a section that we have not seen before, and that is the BSS section. So this section is responsible for defining or declaring an initialized variables or an initialized data into memory. So we saw that we have the .bss section, and also we have the section text. So section data. So this data is for initialized variables or constants. This over here is the opposite of this. So this is an uninitialized variables, or where you want to define a variable that is not initialized. So you maybe request some bytes from memory, then you use them later. So today we'll be using the BSS. So let me do this. Let me delete this one over here. But we'll be combining all the section in our next video by writing maybe a simple calculator or a simple program that will compile what we have been learning so far, using maybe we'll be writing a project to solidify our understanding in the assembly language. But today we'll make it simple, and I will go ahead. So getting user input, you have to move into EAX the system call number 3. So 3 stands for standard input, 4 stands for standard output. So when you want to print it to a terminal, but 3, we are telling the machine that we want to get input from the user through the keyboard. Then we'll move into EBX the value 0. So 0 meaning that we want it to direct the input, or we want to use the keyboard to key in our information. So 0 is something that is called a file descriptor, or simply you can say that is the device that we want to use. So as simple, you can use that simple mental model. Then I will move again into ECX. As usual, ECX expects a pointer where the data will be stored, or you can say maybe a buffer where we'll be storing what the user has put or has keyed in the keyboard. So this is where the .bss comes in. So maybe we want a name. So name, we use RESB in full form, reserve bytes. So we want to reserve some bytes for our name, and then just declare how many bytes do you want. Go ahead and use 1024. Approximately this 1024 bytes, maybe it's a kilobyte. So you can use any number. You can use 10, depending on how long your input will be. So I will use this long byte, 1024 bytes. Then over here ECX will point to the name. Then into EDX expects the length of our variable, which is 1024 again. So like that. Then after doing that, we just call an interrupt 80h to return the control back to the user in order for it to execute each and every command over here. Then after that, we will exit our program successfully by moving again. We will move to EAX the value 1, meaning this is a system call number, meaning sys exit. So I'll link the system call numbers, or the link where you can see or you can read the different system calls inside Linux. Then into EBX we'll move the status code, which is 0. So this is an equivalent of return 0 into like a language like C. Then interrupt the program again. So I will go ahead and maybe we go step by step. So we have declared a .bss section. So in this section is responsible, so used to declare an initialized data or variables. Then this we are telling, so reserve some bytes for later use. Then the section, as usual, this is where we write our source code. So where our source code resides, then this is the normal starting point. Then this is the system call, system call for sysread. So we want to read, is define means that we want to use the system read. Then this is the device, so you can say the device of the descriptor, so e.g. keyboard. Then this is the pointer to our buffer / data, where we will be store what the user has keyed in will be stored into this, and this is the size. So this again, this is the size of the data being processed. So these are comments, so you can ignore them, but I've put them here for BB documentation, that whereby you can understand or know what is what in the source code. Then this is the system exit, the return 0, and the interrupt as usual. So we'll go ahead and try running it, and we'll use our usual NASM assembler. So NASM elf, so we're using that 2-bit, followed by the name of our file, the object file, which will be input.o. It has assembled successfully. Now we have an object file. Then let us create or generate our binary by linking it. So ld elf i3, so we are using the x86 architecture, i386, followed by the name of the object file, input.o, then the show. Now our binary, we will name it again as input. So it has compiled, assembled, and linked successfully. Now we have our binary file. So let us try running it and see what happens. So input. So as you can see, now we have a cursor that expects us to key in something. So you can see, so let me try and maybe type my name. So it has done something, but we haven't written the code to process it. But let us open the debugger and see what exactly that we have placed inside that variable. So as usual, using gidra, so gdb, then the name of our binary, so we'll put it under examination, then layout, ASM, then we make a breakpoint to start, then run. We'll go into each individual instruction until we reached where we have to input something. So step I, so we have moved 3 into EAX. step I, we moved 0 to EBX. Now step I again, we have moved the variable inside ECX, so step I. Now we have reached the interrupt, so if we step I, now we will see a cursor again where we'll be inputting our key or our values using the keyboard. So as you can see, the debugger gives you a leeway to type because we have reached where the computer now calls the system read. So I'll go ahead, and as you can see, it's a cursor that is blinking, so I'll just type my name, maybe like that. So now we have finished. So in order to see what we have keyed in, I'll use this command. So X for examine, we want to examine a string, then we want to see what is in the name variable that we declared in the BSS section. So as I press N, you can see the name that I've keyed in, followed by a new line which has been placed there automatically. So this is the basic system read, but we'll do a part 2 of this, whereby we'll be maybe printing something to the screen, then we take the input and again we return the input, or maybe we take the input, process it, and return a different output. Because so far we have seen the system out, this is the system read. Now we'll be able to write maybe some simple programs, maybe a simple calculator for adding 2 numbers, subtracting two numbers, multiplying 2 numbers, or dividing 2 numbers. So I'm excited in doing that, but this is the basic overview of just taking an input from the user. So as you can see, so it's simple. So you just use you move into EAX the value 3 to tell Linux this is the system read. Use EBX to tell what the machine should redirect the command to. So 0 stands for the keyboard, 1 stands for the screen, yes, and 2 stands for it to do something in the standard error. But we'll be using 0, then followed by the pointer where the data that will be keyed by the user will be stored in this name variable, which we reserved some bytes over here in the .bss section. Then EDX, the size of the data being processed, followed by an interrupt for us to give back control to the operating system for it to execute each and every command over here. Then we do graceful exit by putting 1 system exit and putting 0 into the EBX, and for it this is to indicate it's just a simple return 0. But let us see something. Let me edit something and I'll show you how to view this. So let us return maybe something like 100 and try and recompile it, assemble it again, and link it again. So if we run our program, so input, maybe we put our name, then to see the status or the status code returned, you just use echo followed by a $, followed by a question mark. So you can see our value 100. So this indicates the status code of our program that we have used over here, and which is this value over here. But conventionally use 0 for success, and any non-zero number is for an error status code, meaning something went wrong with our program. So that's simply this system read, or how to get input from the user. But on the next video we'll be writing a more complex or a much easier, it's not that complicated, or a much easier project where we'll be combining what we have learned in those videos, and maybe come up with one project and we do it, which will boost your confidence in writing some more assembly code. So with that, see you on the next video, and I'm excited for the project. So tell me in the comment section, what do you think about the videos? How can I improve the video quality or the explaining? And I'll be happy to help you. And if this video have been helpful to you, just leave a like, subscribe, and just turn on the notification bell for you to be notified when I drop the next video. So thank you for your time. See you on the next one.